Okay, looking into special cases where you might have a linearly dependent system or a repeating eigenvalue. And let's say that if we have a four equation system where we have the first order derivative of x of 1 with respect to t is equal to 5 times x of 1, and that of x of 2 is equal to x of 1 plus 4 times x of 2. And if we have the first order derivative of x of 3 with respect to t and set this equal to x of 3 plus 3 times x of 4 to make up the third equation, and for the fourth equation, we'll say that we have that the first order derivative of x of 4 with respect to t is equal to 4 times x to the fourth. And if we establish a coefficient matrix A, okay, so we have these numbers laid across. They have 5, 0, 0, 0 from what we have in the first equation. The second equation, we have 1, 4, 0, 0. And the third equation, since we have missing x sub 1 and x sub 2 terms, we have 0, 0 at the front. Then we have 1 for x of 3 and 3 for x of 4. And we have with the last equation, we have the only term at 4 times x sub 4. And so we have the last row at 0, 0, 0, and 4. And for a 4 equation system, the identity matrix will be 4 by 4 with the 1 running diagonally from the upper left corner to the right at the lower end. And we have for A minus the product of lambda times I, we have this particular matrix, okay, that is laid out. And if we take the determinant and set equal to 0 to create a pathway to arrive at the eigenvalues, okay, so the determinant of what we have here, and just stressing the signs here. So if I go column by column, again, you have for the odd number column positions, you have taking the positive sign or the same sign. But if you have even valued column positions, okay, you're going to have taking the opposite sign, okay. And we have the only non-negligible expression in the top row, okay, to be in the first column as well, where we have 5 minus lambda. So if I take the positive sign or the same sign, and we have times the 3 by 3 determinant. And what we're going to do here is, if we section out, okay, the items that share the same row as well as the same column, okay, we have 4 minus lambda, 0, 0, 0, 1 minus lambda, 0, 0, 0, 4 minus lambda. And looking at setting things up position-wise, okay, so we have 4 minus lambda in the 3 by 3 column matrix position. Okay, this is in the odd this time around, so we have a plus, we have minus and plus. And looking at distributing 5 minus lambda, and we have times 4 minus lambda, and you have times the 2 by 2 determinant, where we have left exposed 1 minus lambda and zeros, and everything else, okay, we don't even have to apply since we had the remainder of the top row to be 0. And looking at what we have in the mix, so you have 5 minus lambda times 4 minus lambda, and again we have the 2 by 2 determinant, so we have 1 minus lambda times 4 minus lambda, and we have that product is equal to 0. Notice that 4 minus lambda is a repeating linear factor, so in the rewrite, condensing, we have 5 minus lambda times the square of 4 minus lambda times the quantity of 1 minus lambda is equal to 0. And just going factor by factor, we're going to have the first eigenvalue to be at 5, the second, which is 4, and 4 is going to be a repeating eigenvalue on the basis that we have a repeating factor with 4 minus lambda. And from 1 minus lambda, we can say that will form the third eigenvalue, which is going to be at 1. It doesn't matter how you order these, but letting 5 be the first eigenvalue, and we have in the arrival at the determination of the first eigenvector, again for A minus 5 times the identity matrix. Okay, so you have this array, first eigenvector we have in the general layout, we have with the elements, we have A sub 1, B sub 1, C sub 1, and D sub 1, and we have is equal to 0, which we have expressed as a 4 by 1 matrix exclusively with the number 0. And if we form an augmented matrix combining what we have with a minus 5i with the 0 matrix, and we have in the reduced row echelon form, we have running across, we have 1, -1, zeros for the rest, and this is going to signify that a sub 1 minus b sub 1 is equal to 0, from which we're going to have that a sub 1 is equal to b sub 1. Next row, we would anticipate normally the solution for b sub 1, but for what we have instead, we have 0, 0, 1, 0, 0, and that 1 signifies the c sub 1 position, and that is automatically equal to 0. Next row, we have 0, 0, 0, 1, 0, and this one is in reference to d sub 1, and that is equal to 0, but there's nothing with 1 isolated in the second column, and so this is going to signify that b sub 1 is a free variable, and here we're going to assign a variable letting b sub 1 be equal to t. So for the first eigenvector, we have again, so we have a sub 1, b sub 1, c sub 1, and d sub 1. Again, c sub 1 and d sub 1 are negligible, and again, a sub 1 and b sub 1 are the same, and if we let b sub 1 be equal to t, we have, again, for our 4 elements, we have t, t, 0, and 0, and factoring out the variable in t, okay, and this is the only variable that we have within this matrix, and so we have factoring out t, so we have 1, 1, 0, 0, and using what's going to be referred to as a basis matrix, if we factor out the variable and just let that variable be equal to 1, in this case t is equal to 1, we're going to have 1, 1, 0, 0 to be the elements that will represent v sub 1. And with the second eigenvalue at 4, okay, we have for a minus 4i, again we have this 4 by 4 setup, v sub 2, again we have with the general elements a sub 2, b sub 2, c sub 2, and d sub 2, and again we have is equal to 0. So putting in augmented matrix terms, okay, and performing the reduced row echelon form, notice we have with the 1 and the 0s running across, okay, we have a sub 2 is equal to 0. Next statement, or next row, we have 0, 0, 1, -1, 0, and here this is going to signify that c sub 2 minus d sub 2 is equal to 0, and we had that c sub 2 is equal to d sub 2, and since we have neither the second column or the fourth column to have 1 isolated, that means that b sub 2 is a free variable, and d sub 2 is going to be likewise. And since we have 2 free variables, okay, we can say that b sub 2 will let this be equal to s, and we'll say that with d sub 2 as the last free variable, we'll let this be equal to t, and also due to the fact that c sub 2 is equal to d sub 2, we'll have c sub 2 equal to t as well. So we have for the second eigenvector, again, so you have a sub 2, b sub 2, along with c and d sub 2, and assigning the variables s and t respectively. So a sub 2, again we have 0, b sub 2 is at s, c sub 2 and d sub 2 are each going to be at t, and if we factor out the variables and separate, okay, so if I factor out s, itemize, okay, so we got, 0, 1, since we factor out s from the second row, okay, and since we don't have an s term in the bottom 2 rows, we have 0 and 0 to follow. And then for the next, okay, if we isolate or factor out t, we have plus t, and looking at factoring out t, so we have 0, and since s does not have any capacity of any factor in t, that is also 0, and we have 1 and 1. And likewise, if you were to add together, you have like 0, s plus 0 is s, 0 plus t is t, 0 plus t is t, and letting s and t again be at 1. And for what we have with the 4 by 1 matrices factored out and using the bases, in this case, we can say that we have v sub 2, again we have 0, 1, 0, 0, from letting s be equal to 1, and then we have plus 0, 0, 1, 1 upon letting t also be equal to 1. And for what we have in the case of the third eigenvalue, okay, which is 1, and looking for the third eigenvector, and again you have your a minus 1i, and you got your v sub 3 equal to 0, and setting up what we have as an augmented matrix that we have upon consolidating the matrices of a minus lambda I as well as the 0 matrix and putting in reduced row echelon form. So for the top row we have a sub 3 is equal to 0. Next row we now have b sub 3 is equal to 0. And then next row, okay, we have 1 isolated in the fourth column, and this is going to signify that d sub 3 is equal to 0. And since we do not have 1 isolated in the third column, c sub 3 is going to be the only free variable, and we will let this be equal to t. And so we have for v sub 3, okay, with c sub 3 equal to t, everything else negligible, we're going to have v sub 3 is equal to t times 0, 0, 1, 0. And again, going with the basis upon letting t be equal to 1, we'll say that v sub 3 is equal to the 4 by 1 matrix, where we have going from the top to the bottom the elements 0, 0, 1, and 0. And looking at what we have for the solution set, so we have for x, again we have x is equal to c sub 1 times v sub 1 times e to the first eigenvalue times t. And now with 4 as a repeating eigenvalue, we wound up having distinct eigenvectors in the basis to be spun off. So if we itemize each of the basis vectors, let's say we have c sub 2 times 0, 1, 0, 0 times e to the 4t, and then branching out, let's say we have a distinct constant with c sub 3 times the other part of the second eigenvector. We have that times the matrix consisting of 0, 0, 1, 1 times e to the 4t once again. And we have with c sub 4 times the third eigenvector times e to the 1t. And looking at it layer by layer. Okay, so we have for x sub 1, looking at the top row, and we have only c sub 1 times e to the 5t. For x sub 2, okay, we're going to have c sub 1 e to the 5t plus c sub 2 e to the 4t, and everything else is negligible for x sub 2. X sub 3, okay, we have nothing for e to the 5t. First half we have nothing for e to the 4t, but for the second half we do have c sub 3 e to the 4t, and we have plus c sub 4 e to the t. And for x sub 4, the only non-negligible existence is going to be c sub 3 times e raised to the 4t. Now say if we look at some of the simpler equation systems, but that might have a bit of a twist added. And let's say that if we have the first order derivative of x sub 1 with respect to t is equal to 2 times x sub 1, and that the first order derivative of x sub 2 with respect to t is equal to 2 times x sub 2. So your coefficient matrix will have 2, 0 at the top row, 0, 2 on the bottom row. And again, the identity matrix, we have 1, 0, 0, 1. And for a minus lambda I, we have, again, 2 minus lambda, 0, 0, 2 minus lambda. And looking at the determinant, notice we're going to end up with the square of 2 minus lambda. And there's going to be only one existing eigenvalue, and that is going to be 2, which is going to repeat. And so looking at the formation of the eigenvector v sub 1, and if you notice we have with the subtraction of the eigenvalue of 2, okay, we're going to end up with exclusively zeros. And just putting it in terms of the augmented matrix, this is already laid out in reduced row echelon form. So both a sub 1 and b sub 1 are free variables. And we'll say that a sub 1 is equal to s, while b sub 1 is equal to t. And so we have for the items here, if we have v sub 1, again, equal to a sub 1 over b sub 1, and we have with a sub 1 at s, b sub 1 at t, and then just branch out. So we have s times the matrix 1 and 0 plus t times the matrix consisting of 0 and 1. And if we let both s and t be equal to 1 and just use the basis vectors, we can say that v sub 1 is equal to the sum of these 2 by 1 matrices. We have 1, 0 plus 0, 1. And then looking at what we have in the system. So we can say that for x, we can say is equal to c sub 1 times the first basis vector times e to the 2t. And you have plus c sub 2 times the second basis of the first vector, where we have 0, 1, and then we have times e to the 2t. And looking at what we have going layer by layer. So x sub 1 is equal to c sub 1 times e to the 2t, and x sub 2 is equal to c sub 2 times e raised to the 2t. And that would be your solution in this case. And something that will have sort of a similar appearance. Let's say if you have the same condition for the first order derivative of x sub 1, but we'll say that we had the first order derivative of x sub 2 be equal to x sub 2. So your coefficient matrix will consist of 2, 0 at the top, 0, 1 on the bottom, and with the identity matrix again in the 2 by 2 array. And we're going to have for a minus lambda I, so we're going to have 2 minus lambda, 0, 0, 1 minus lambda, and attaining the determinant upon setting it equal to 0, and thus forming the eigenvalues. So we have 2 minus lambda times 1 minus lambda. Other diagonal product is already negligible, so right away we have our two eigenvalues to be 2 and 1, and we can just say that the first eigenvalue is equal to 2 and the second is equal to 1, and looking at establishing the eigenvectors. So using the first eigenvalue, letting that be equal to 2, we're going to have for a minus 2i, we have 0, 0, 0, negative 1, and with v sub 1 consisting of a sub 1 and b sub 1, and again we have our 0 matrix with zeros exclusively. And for what we have in augmented terms, and setting things up, so we have zeros across, 0, negative 1, 0 on the bottom, and looking at what we have in reduced row echelon form. So we have 0, 1, 0, and zeros across, and the top row signifies that b sub 1 is equal to 0, and we do not have 1 isolated in any capacity from the first column. So a sub 1 is a free variable, and we will let that be equal to t. So v sub 1 we can say is equal to the 2 by 1 matrix consisting of t and 0, and setting things up where we will just use the basis of this vector, factoring out t and letting it be equal to 1. We'll just say that v sub 1 is equal to the basis vector consisting of 1 at the top and 0 on the bottom. And for what we have for the second eigenvector, okay, with the value eigenvalue at 1, so we're already going to have the augmented matrix to be expressed in reduced row echelon form, because we have 1, 0, 0, zeros on the bottom. A sub 2 is automatically equal to 0, and b sub 2 is equal to a free variable, and if we let this be equal to t, so we have for v sub 2, okay, substituting t for b sub 2, so we have 0 and t, and establishing the basis vector component. Okay, so if we factor out t, okay, so you have t times the matrix consisting of 0 and 1, again letting t be equal to 1. So we'll say that v sub 2 is equal to its basis, which we have at 0 and 1, and carrying over to what we have in arriving at the solution set. So we have c sub 1 times the first basis, and in this case we have 1, 0, we have e to the 2t, and we have plus c sub 2 times the second basis 0, 1, e to the t. And so looking at what we have for the first x value, so we have, or first x general solution, so you have c sub 1 e to the 2t, and c sub 2 times it, well that's going to be negligible. And for x sub 2, okay, it is negligible in e to the 2t. However, we have c2 e to the t, and that is going to be a general solution for what we have in the case of this particular system.